What's up everyone, welcome back. Patrick here, moving on to the next video dealing with decomposition. This is a pretty cool question. So what we got to do, we got to find two values of b in each of these over here so that each of these expressions can be factored. So this is a fairly unique type of question. We're sort of going to be going backwards. Now, when I'm doing this, I'm assuming that you've watched all of the videos in this section up until this point. You watched all the decomposition videos and you're fairly familiar with the process, because there's going to be just small things we're going to be doing where I'm assuming that you've gone through that process many times. And so hopefully you're watching this on the website following in order. If you're not, you can go to the description box. There's a course link where you can follow the videos in order, and make sure you do so because there's lots of carryover as the videos go on. And in this particular video, there's lots of carryover from those previous decomposition videos that we've done. Right, so let's start off with this one. We have x squared plus bx plus 18 over here. Now, if you remember, with decomposition, when is an expression able to be factored? How do we know when an expression is able to be factored? Well, when we can find two numbers that multiply to the a and the c value, in this case it's 1 and 18 multiplied, and then add up to the b value. So both of those numbers have to multiply to the ac value, and they have to add up to the b value. And if you could find two integers that satisfy this over here, then you know that your expression can be factored. And so that's what you want to do with these kinds of questions. You basically want to find two numbers that are going to satisfy this, and then whatever variable or whatever coefficient rather you're looking for. In this case it's going to be the b value, and the next video we'll be looking for the c value. If you could find two numbers, then you finish the question basically. So let me show you what I mean here. So let's first write out, we got the a value of 1, the b value, that's actually what we're solving for, and then we have a c value of 18. So what's this ac value going to be? Well, it's going to be 1 times 18, right? So it's going to be 18 as well, the same as the c value. That's not always going to happen, right? This a value is not always going to be 1, but in this case, the AC is the same as the c value because that a value is 1. And so now all you want to do is basically plug in 18 for the AC value. And in this particular case, you want to find two numbers that multiply to positive 18, that multiply to that AC value of 18, and then also add up to the b value, but the b value is actually what we're solving for. So really all you have to do is find two factors of positive 18, and then you get your b value. So it's actually not too bad. So there's actually an infinite amount of answers, so that's why I wrote find two values of b, but there's actually more than two values in most cases that you can find. So there's two different ways to find the values, or find different values, differentiate between them. You can find different factors. So notice 18. What are some factors, or what are some combinations of numbers that can multiply to give you 18? Well, it could be 1 times 18. That's 1. Maybe 2 times 9, 3 times 6, right? All of those work right there. So one way to differentiate these numbers is by the different factors that can multiply by each other. But another way, because we're dealing with positive 18, is to actually switch the signs as well. Because if you notice, positive 1 times positive 18 gives us positive 18, but also negative 1 times negative 18 gives us positive 18. Or negative 2 times negative 9. Or negative 3 times negative 6. Right? All of these multiplied give us positive 18, right? And so notice that all of these, when you add them up, they'll give you a different b value. So really, there's 6 different choices we have. In this case, we're only going to do 2, right? You only have to pick 2 of these combinations. But notice that there's a total of 6 that you could pick. So let's say we go with the first one. We got +1 and 18. So that means it's going to be +1 and 18. So what's 1 plus 18? Well, it's going to be 19. So that's a b value. Let's let me erase this here. And then I'll write these as we go on. So a b value, a potential b value, is 19. Right? And so if the b value is 19, right, notice that we can, here's a good way to check your answer actually if you want. Notice that we can decompose that 19 into those 2 factors and then just make sure that this factors properly. Or sorry, here we'll take out a +1, my bad. Right, so erase this. Notice we could take out a x plus 18 from both of these and we're left with an x plus 1. So notice if that b value is 19 for this expression, that expression is going to factor into these 2 over here. So you could always check your answer with this as well. When you plug in your b values, if you have time on a test, you can actually take that expression and just make sure that it factors. But if you did those steps correctly where you found those 2 numbers, right, then it should be all good. Then you don't necessarily have to do this step, but it's a nice way to check. Now, what if we take another combination? So let's do this maybe -2, -9. So -2 times -9 gives us +18. -2 plus -9, what would that give us? That would be like -2 minus 9, which would give us -11. Okay, so another potential combination is the b value being -11. And so what you would have here is you would have plus -11x, and then the plus and minus turn into a minus. The reason why I want to mention this and put this in brackets is because it's going to be more important actually in parts B and C when we have this negative in front, but we'll get there. But if the b value is -11, so you'll have plus minus, and then that plus minus would turn into just a single minus, so you'd end up having minus 11x over here. And then if you want to do a check, again, you can do the decomposition here. So this is going to be what? -2 minus 9, so -2x minus 9x plus 18. From these 2, we could take out an x. From these 2, we could take out a -9, and we're left with x minus 2. And then we could take out an x minus 2, and we have an x minus 9, like that. Right? And then if you want to check this, you can expand it, make sure you get that expression, right? So a b value of -11 works as well. But if you go through all these, this would be a b value of +11, this would be a b value of 9, -19, -11, which we just did, -9, right? So you got a lot of different potential answers for part A. It's not always going to happen just because in this case, this 18 has a lot of factors, right? There's not going to be as many factors for this -6, for example, but sometimes you'll get a large choice like that you can pick from. Okay, but from these, for the +19, I chose this, and then I also chose that right there. But you could choose whichever ones you want. Right, so that's pretty much how you do it. So moving on to the next one. So we got x squared minus bx minus 6. Sometimes you'll see this negative over here. And what they're trying to do here, if they put a negative, is they just want you to put a positive b value here, so then you'll have minus, let's say the b value is going to be, I don't know, 1. So you'll have minus 1x right here. But this b value could also be a negative, and then you'll have a negative, and it will turn into a positive. So I'm going to show you in a sec how that works. But for now, let's just go through that process again. So we got that a value of 1, we got the b value of negative b. Let me think what to do here. You know what? Let's just put the b value as a question mark over here for now. So we'll have a c value of -6. And so what's the process then? AC -6, like that. So then we got to find two numbers that multiply to -6 and then add up to a certain b value. That's what we're going to be solving for. Don't worry about this sign here. We'll take care of that in a sec. So because we're finding two numbers that multiply to a negative value, notice that these two numbers, it has to be a combination of what? Positive and negative values, right? So if we take this -6, let's break it down into some factors. So we could have -6, +1. We could have +6, -1. We can have -3, +2. We could have +3, -2. And I think that is all in terms of the integers, right? Yes. Right, so all of these here, they work. So let's try a combination here. So let's maybe try this first one. So we got -6 and +1. So if we choose that combination, we'll have -6, +1, and then -6 + 1. What is that going to give us? That there is going to give us -5. Now you got to be careful here, because this -5 here, it's basically going to be this entire expression. So what you got to end up with is x squared minus 5x minus 6, like that, right? This b value here, because over here we have like a negative b, this is actually, it's kind of tough to explain. So this is actually not like the actual b value of that standard form ax squared plus bx plus c. You could even use a different variable here. Let's maybe use m. That might be better, right? Whenever you have like a minus here, it might be better to put in a different variable because you might start getting confused a little bit. This -5, it means that this entire b value here has to be -5. So let's just forget about this. We know just from previous decomposition, right? If we have a combination like this -5 is going to end up being this b value over here. And then what we can do, we can decompose that, right? Just to make sure that it factors. Take out the x minus 6 and we're left with x plus 1, right? So if we end up having this combination here, it's going to factor to that. So the b value here has to be -5. So what does that m value here have to be? Basically, if you think about it, this -m has to equal this -5. And then you could just divide both sides by -1, so the m value is 5, right? So over here, it was x squared minus mx minus 6. So what we're plugging in for this m is just +5, because then we're going to end up with x squared minus 5x over here. Okay, so what I'm going to do actually is whenever there's a negative, I'm going to change it to m, so you're not getting too confused with this b value. This here represents that overall expression versus m is just like within that expression because there's that negative there. So a combination is m is equal to +5, right? So that would work out. If it's +5, then you're going to end up with that expression, which factors as we saw. But let's try a different combination. Let's actually try the next one, where we got +6 times -1. So we know two numbers that multiply to -6, and what are they going to add up to? What's that b value going to be? Well, if we use +6 and -1, +6 and -1, notice 6 times -1 does indeed give us -6. What's 6 plus -1? It's going to be 6 minus 1, which would give us +5. So actually, in this particular case, another combination that works is x squared plus 5x minus 6, like that, right? This represents that entire b value. And just to confirm that this works, what we could do is we can decompose like that. From these two, we could take out an x. From these two, we could take out a -1. Right? All of the signs change when we take out a -1. Then we could take out an x plus 6. And then we're left with that x minus 1 over here. So if it's positive 5, this is what it's going to factor into. So notice the one before, it was x minus 6 times x positive 1. In this case, it's x plus 6, x minus 1. So if it's positive 5, it factors into that. So positive 5 for the b value works, but then what's that m value going to be? Well, if you look at this, basically this negative m has to equal positive 5 in this case. And then if we divide by -1 to get the m by itself, m would be -5. Okay, so that's actually another combination that works. All right, hopefully you're not getting just basically thrown off by this negative. And basically if we take this m value of -5 and plug it in here, what we would end up having is x squared minus -5x minus 6, right? Plugging in -5 for this m, that's like in brackets, and then this negative would turn into a positive. All right, so if m is -5, then the b value is going to be positive 5. Okay, if the m value is positive 5, then the b value is going to end up being -5, like we had before. So don't let these negatives here confuse you, right? Usually what they're looking for is just a positive value for you to plug in here. So they want you to plug in like a positive 5, and then it would end up being x squared minus 5x minus 6. So usually at the back of a textbook, if you get something like this, the answers here would be positive. The other positive answer would be if you use this combination. So what if we use that combination here? Let's see what happens. What am I erasing here? Yeah, so two numbers that multiply to -6, what b value are they going to add up to? So if we use -3 and +2, -3, +2, this multiplied gives us -6, -3 plus 2 would give us -1. So that would end up being the entire b value, so we would end up with x squared minus x minus 6. And if you follow the whole decomposition process, the final answer that it's going to factor to is x minus 3x plus 2, like that. But the entire b value is -1, so what's that m value going to be? Well, we're going to have -m has to equal that -1, so to get the m by itself, divide both sides by -1. M is going to be +1 in this case, right? So that's another, let me erase this here. That's another combination. If we plug in an m value of +1, we'd end up with this, x squared minus x minus 6, right? And so the back of a textbook is usually going to give you these two answers over here. But technically, you can also plug in negative values here, because then the two negatives would turn into a positive. So now let's do that last combination. So in this case, I want to do a few more just because of this negative, just so you really understand what's happening. So if I plug in +3 and -2, +3, -2. 3 times -2 is -6. 3 plus -2 would be like 3 minus 2, which would give us +1. So another combination is if that entire b value is just +1x, right? Which would just be plus x. You don't have to put the +1. If it's like this and you do the decomposition process like we've been doing before, you'd end up with x plus 3, x minus 2. So that happens if the b value is +1, but what would that m value have to be? Well, -m, we have to turn this -m, this entire thing right here, into positive 1. And dividing by negative 1 to get the m by itself, that's going to happen when m is negative 1. Right? So technically, all 4 of these work over here. But again, usually a textbook, when you have like a minus over here, they're just assuming you're plugging in these positives to turn that b value, that entire b value, into a minus. So if you do end up seeing questions like this where they have this minus bx, or sometimes they'll have like minus c, I actually recommend changing the variable to something else so you're not getting confused with that entire b value, because usually what's the standard form of a quadratic? It's ax squared plus bx plus c, right? It's not minus b over here. So this b value and the b value that they give you here, it's actually different, if that makes sense, right? Basically, if you get a negative bx, just change it to m, and then just follow this process, and then just solve for the b value, plug in, and then find out when is negative m going to equal that b value, and then get your m value. So now moving on to part C, notice this one, it's actually going to be very similar because again we have this negative m over here. So let's, if you're confused with the last one, maybe when we're starting from scratch here again, this will make perhaps a little bit more sense to you. So in this case, the a value is 1, okay? The b value is what we're solving for. It's actually equal, the b value in this case is equal to negative m, but we'll take care of that at the end. The c value is positive 12, right? So then we got to get the ac value, which in this case is just positive 12. And so then we got to find two numbers that multiply to positive 12, and then we're solving for the b value, so what are those two numbers going to add up to, right? That's going to give us our b value over here. And then we could solve for our m value right here by letting that negative m equal whatever we get here. So what are some factors of positive 12? What's going to work? Well, 6 and 2 would work. So what's 6 plus 2? Well, that would give us positive 8, right? So if we have x squared plus 8x, let me put this a little lower actually. Right? That's going to work right there. And just to confirm, if you want to do the actual factoring, decompose it, just to fully check, we could take out an x from these two, 6, right? Plus 2, we could take out a 2 from these two. This bracket should be the same, so then we could take out an x plus 6, and we end up with x plus 6 times x plus 2. So if the b value, if that entire b value is positive 8, it's going to factor into those two right there. Okay, so now going back, when is negative m equal to positive 8? When do we get a positive 8? Well, divide both sides by negative 1, and we'd end up with m equaling negative 8. So that's actually one of the combinations that works, because if we plug in negative 8 over here, we'd end up with x squared minus negative 8x plus 12. Those two negatives turn into that positive. And it's not always actually going to just be mx. If this was to be more complex, maybe you'll get something like negative 2mx that you have to solve for, right? So then this entire expression has to equal that. So then you'd plug in negative 2 over here, divide both sides by negative 2, right? Those would cancel out, and you'd end up with an m value of negative 4. Okay, so that can also happen. In this case, these were more simple. Now that I'm thinking about it, I could have maybe added some extra coefficients in front. like numbers, but it's not too big of a deal if that happens. It's just this last part is going to be different, right? So just solve for the actual quadratic first, what the quadratic should be in that standard form, and then go back and see what's the format you were given and see how, with the format you were given, what you could plug in order to get that quadratic that you got from this step over here. Okay. So we got x squared minus mx plus 12. Okay, let's try something else here. Notice that actually, because we have a positive 12, notice that negative 2 and negative 6 and negative 2 work as well. Negative 6 times negative 2 gives us positive 12. What's that going to be? Negative 6 plus negative 2 is like negative 6 minus 2, which gives us negative 8. Okay, so another quadratic that would work here is that right there, where the b value is going to be negative 8. And if you do the decomposition, what it's going to factor to is x minus 6, x minus 2. So if it's negative 8 over here, it factors into those two. But going back, what can we plug in here for the m value to get negative 8? Well, divide both sides by negative 1. The m would be positive 8. So m equaling positive 8 works as well. Okay, let's try a different combination of numbers here. So what other factors of 12 can we use? Let's say negative 4 and negative 3. Right? Negative 4 times negative 3 gives us positive 12. What's negative 4 plus negative 3 going to be? That's going to give us negative 7. Right? Negative 4 minus 3 gives us negative 7. So another quadratic that works, that can factor, is x squared minus 7x plus 12. And what that's going to factor to is x minus 4, x minus 3. Like that. So what can we plug in here to get to here? Or when is negative m going to equal negative 7? Divide by negative 1. It's when m is going to be positive 7. So that's another combination. But then you could also do positive 4, positive 3, positive 4, positive 3. That will give you positive 7. So positive 7 works here. That would factor into that. And then when does negative m equal positive 7? Well, that's going to happen when m is negative 7. So that's another combination that's going to work. Also, what's going to work? Negative 12, negative 1. Negative 12, negative 1 would be negative 13. Right? Let me erase those. Right? Negative 13. So you'd end up with minus 13x over here. If you have minus 13x there, it would factor into x minus 12x minus 1. But then when does negative m equal negative 13? That's going to happen when m is positive 13. All right, so that's another combination over here that you could use. Right, so an infinite amount of combinations. So don't get confused if you see this negative over here. You're just basically flipping the sign. Right, so hopefully you're seeing the pattern at this point of what is happening. And then moving on to part D, we got x squared plus bx minus 21. So in this case, it's nice. We don't have to worry about that whole step at the end of dividing by negative 1 to get this value, because it's already a positive b. And it's in line with that standard form. The standard form also has positive b. Right? It doesn't have a negative b over here, and that's why we had to adjust that right there. But here it's already in line with this, which is nice. So really all we got to do is, let's write this over here. A value is what? 1. B value is what we're solving for. The C value is negative 21. AC, negative 21. So we just got to find two numbers that multiply to negative 21. and then the b value is what we're solving for. Okay, so you could pick different combinations. So -7 and +3 work, right? -7 times 3 gives us -21. What's -7 plus 3 going to be? That's going to give us -4. So x squared minus 4x minus 21 is a quadratic that factors. If you do the decomposition process, which we've gone through countless times, so I'm just going to give you the final answer, it's going to factor into that, right? So notice, when is this positive b going to equal -4? Well, basically when the b value is -4. We don't have to worry about switching the sign because it's a positive over here. If we plug in -4 for this b, we end up with that quadratic. Okay, what's another combination that works? Well, because this is a negative, we can just switch these. So we can have a +7 and a -3, +7, -3. That would end up being +4, +4, and then those would be, that would be positive, this would be negative. If that combination happens, right? This would factor into that. So +4 works as well. Okay, what else is going to work? 7 and 3. I think actually 21 and 1 is the only other thing that could work, right? So if we have like -21 +1, -21 +1, that would give us what? -20. Give me a sec here. Yes, -21 times 1 gives us -21, right? -21 plus 1 gives us -20. I blanked out there for a sec. So a combination that also works is x squared minus 20x minus 21, like that. Okay, and what this would factor into is x minus 21, x plus 1. If you expand this, you'd end up with that, right? So another combination or another b value would be -20 that we could plug in. You could also, though, switch the signs, make this a -1, but then we'll have 21 plus -1, which is like 21 minus 1, which would give us +20. So if we have +20 here, then these signs would change. We'd have a +21, we'd have a -1, right? So the b value can also be +20, all right? So I think this one, it only has 4 different options. These are all the options here for part D, right? So for basically most of these, I gave you more than 2 options just because I really wanted you to understand what's going on. So hopefully from this video, you understand the process and don't get confused with this negative. And again, as I mentioned, maybe I'll actually make a video making these more complex. It doesn't have to just be like a -m or a -bx or a +bx. This could be more complex. There could be another, this could be like a more complex expression over here. Okay, but if that happens, all you have to do, same process applies, is just at the end when we let that -m equal that b value that we got, you just have to let that expression there that you get equal that b value, and then you just solve for the variable. So it's not too big of a deal. It's just that ending is a little bit more complex, right? Now, in the next video, what we're going to do, similar question, but now what's going to be unknown is the c value.